Ladies and gentlemen, please welcome Ken Bereskin.
Good afternoon, everybody. Why don't we reverse our slides a little? There we go. Well, it's May 10th. We're at the Worldwide Developer Conference. This truly is the big software forum at Apple Computer. There's a fantastic keynote with Steve Jobs and Avi Tevanian with demo help from Phil Schiller. I play a very, very important role in the conference this year. I am the bridge, I am the transition from the high-level marketing keynote presentation to the rest of the week, which we promise and guarantee is chock full of technical facts, details, and all of the information that you need for planning your products today and moving forward. So it really is my pleasure to spend a couple minutes highlighting macOS X at a high level. We have Bertrand Serlet, who will take us through the technology and the architecture in much more depth. And we have a number of demos of, excuse me, of the system in its running state today. So it's going to be a very action-packed and information-filled hour. So let's talk about macOS X and some of the fundamental goals and the key principles that drive us. You know, from my perspective in product marketing, there really are 4 simple things that we're trying to achieve with macOS X. Certainly, what really drives us is we believe we're building the future of macOS for at least the next decade. We want to make sure that we get the architecture right. We want to make sure that we get all of the flexibility, the performance, the right set of APIs, the right set of tools, so that we'll drive the Apple platform for another great 10 or 15 years as we've been served incredibly well up to this point. And that really implies a couple technical requirements and technical needs. Certainly the word modern has been overused and abused. We search every year to find a better word to describe an operating that is constructed in a very sound architecture that delivers full preemptive multitasking, full memory protection services, basically having the operating system do as much of the work on the behalf of you, your products, and our customers as possible. Chief among that also is having modern applications, applications that run on the system and exploit all of the capabilities that are provided by the base system. It really doesn't do our customers any good if there's flashy, innovative new technologies in the system that aren't utilized by your application. So that really is a key element. That's why we spent so much time on Carbon over the last year and have a variety of application technologies that will be highlighted in this session and the rest of the week. Now, to build such a system, clearly we could start from ground zero and build that up from scratch. Last year we shared with you the fact that we're not doing that. We're not taking that approach with macOS X. We want to leverage existing technology, existing source, existing standards where it makes sense for us so that we, A, don't have to deliver it and invent it ourselves, and B, it gives us a greater degree of interoperability, a greater connection with the community. Literally, open source has changed the foundation of how software projects are built. It's a long-standing tradition for development in the internet and Unix space, and we're continuing to invest very, very heavily in that. Both as a receiver, we ship the Mach microkernel, the BSD environment. On our server product, we're shipping Apache. So we certainly have gained great benefit from this open model of software development. But we're also giving back. We have a really top-notch operating system development team that has been making the kernel far superior than it's been in the past, improvements to the networking and I/O subsystems. And we are contributing that operating system foundation back to the community as part of the Darwin project. And that really does serve as the basis of macOS X. Now, leveraging existing standards, existing code, contributing in the open source space is essential and really key for our success. We really believe that this is the way that modern operating systems and large projects are going to be developed in the future. It remains the case, though, that Apple does incredibly well when we pick specific focus areas, differentiate, and innovate. And we certainly have a number of key areas higher in the application stack, the graphics model, the desktop user interface, some of the application technologies that you depend on, that we believe are our core competency. It's where Apple really adds value to the system, and we will certainly prove to the world again that Apple can innovate in system software. So as we take a look at macOS 10, I think it's great for us to start taking a look at the current macOS products, macOS 8, because there is exceptional capabilities and technologies that has driven the Mac platform to where it is today. I see a packed Hall 2. This developer conference has gone through ebbs and flows. It's great to see the level of energy this year. It's all a testament to how strong a platform that macOS has been. And macOS 8 in particular, the current release, macOS 8.6 shipping today, has a number of key positive elements and attributes to it. Millions and millions of happy, loyal customers that relish using new versions of the operating system, and the tens of thousands of applications that are available for it. We continue to push the boundaries of how a computer system should be easy to use, easy to get connected to the internet, and a variety of just incredible technologies that have been developed to date. This is a key asset and a very key basic technology that plays an exceptionally important role in macOS 10. Another key product and key technology base also plays an exceptional role in building macOS 10, namely macOS 10 Server. We started shipping this in March. It's proven itself to be an incredibly high-performance, industrial-strength server platform that meets the needs of our customers that are looking for a great internet and web server, for customers in the education markets that are looking for really a new way to set up a network of Macs, making it as easy to manage a network as it is to manage a single system through the NetBoot technology and the ability to host individual users and system images from a single file server. This product is in GM form, delivers early versions of many of the key underlying technologies that play an essential role in macOS 10 desktop shipping early next year, namely the Mach microkernel, the full BSD environment. Our networking environment is based on the BSD heritage, and we've optimized and tuned that and proven that this is an incredibly high-performance platform. In fact, we did a lot of benchmarking with the ZD Tag organization. It's an independent testing body that companies and magazines use. And macOS 10 Server has proven itself to be the fastest Apache platform on the planet. We tested against a loaded Pentium 2 450 running Linux and Windows NT, a Sun Ultra Enterprise 10S, their highest performance workgroup department level server, and Apache on macOS 10 Server running on a PowerMac G3 running at 400 megahertz was by far the fastest of all of the Apache platforms tested. And that, again, is to the heritage of the Mach kernel, the BSD environment, but more importantly, I think the optimization and the tuning that Apple engineers put into that base. We've contributed the changes to Apache back to the Apache group, fully participating in this open source environment. So here we have two products, incredible attributes, strengths in technologies, strengths in markets. The task at hand with macOS 10 is to combine those strengths. We want to build a product that has all of the positive attributes of macOS and all of the positive attributes of macOS 10 Server, and we want to get there in a transition that is easy for you to make sure that your applications come along for the ride. Clearly, we can't ship an operating system that doesn't have the applications that our customers need. And last year, when we unveiled the macOS 10 strategy, we also unveiled a key component, Carbon. Carbon is the subset of the Mac toolbox that we are moving over to sit on top of the macOS 10 base. Our goal is to make this a tune-up for you. As you're planning a major revision cycle, you should be able to factor carbonization in as any one of the other features you'd have on your feature list. From my perspective, it should be as simple as taking these two CDs, magically combining the bits together, and at the other end, getting a product that truly is the best of both worlds. It has all of the positive attributes of macOS, its user experience, all of its applications, its key technologies, and all of the attributes of the rock-solid high performance that macOS 10 Server offers. That's a very, very broad, high-level overview of our goals. This is a technical conference. The rest of the week is intended to allow you to get as much information as possible. So it's my pleasure to introduce Bertrand Serlet, the Vice President of macOS 10 Engineering, to take us through the project at a much more technical level. Bertrand.
good afternoon. Ken made it really easy. You take the macOS 8 CD, the macOS 10 server CD, you take a few bits of each, sprinkle a little bit of carbon crystals, and that's what you have, macOS 10. So, of course, the engineering reality is a little bit more interesting. So this is what I'm going to cover today. And in particular, we don't just randomly kind of mix up those bits. We have, in fact, some very strong design goals, okay, that we want to meet, engineering design goals for macOS 10. Because when you design a new platform like macOS 10, you design it for a long time. It has to last at least a decade. So, of course, one of our goals is totally in line with the marketing goals, which is to make a great platform to run Carbon applications. But also, we want to do the right thing from the architecture standpoint. And doing the right thing from the architecture is, for something like a platform like that, is having a very layered system. Layers are good because you devise some very strong APIs between the layers that enable you over time, as the technology changes or the requirement changes, to substitute component by component without disrupting the whole stack. And this is exactly what we've done, okay, over a while, and what we are continuing to do. And this is great. This is how a layered system should be built. This is all platforms should be built that way. Also, because we have this layered approach, we can use the same base system for both the desktop and the server. This is, I think, a tremendous advantage that Apple is going to have moving forward. I'm sure many of you are aware that the folks in Redmond have given up on the convergence, at least for a while. And so right off the bat, we will have a converged kind of story, a converged system. We are not very interested in reinventing the wheel. So we are going to take components that come from standards, all the ones that make sense. We don't just want to add up, standards just to have check of item. Again, this is, my engineering design goals here. So we take the components that make sense, that are standard, and integrate that into our system. Along the way, we may actually give back some of the components via the open source mechanism to the community, which I think is a great benefit for everyone. And last but not least, Apple has had a long heritage in leading in technologies all the way from hardware to software. FireWire, USB, QuickTime, I mean, it's all over the map. And we want to have a great platform to innovate moving forward. So again, this is a picture that Ken presented, and this is what I'm going to explain, how you build up macOS 10. And because I'm in engineering, I'm going to revert to a classical engineering diagram, architectural diagrams. And this is the story of the presentation, is building up the stack. So there are many ways you can devise an architecture, and you can draw those boxes. What I've chosen is a somewhat classical way to have at the bottom of the stack the kernel and the core OS, if you want. Above that, to have the primary means to communicate with the user, which is a graphic subsystem, the one that's responsible for redispatching user events and the like. Above that, to have the various application models that we support. And the last thing that we provide is the user experience with some of the system applications that come along with the system. So if you look at macOS 10 server, the structure looks very similar. It totally fits that pattern. This is the proper structure. And even though we're not going to take all the components of macOS 10 server, we'll definitely take this decomposition because it's just the right way to have an architecture. So very briefly, at the bottom of the stack, you have Mach 2.5, okay, which is our kernel base, along with Unix, with BSD. Continuing to go up, you have Display PostScript in macOS 10 server. You have 3 application frameworks that are supported, 3 application models. And you have the Workspace for the primary user interface. So let me first focus on the lowest level, which is the kernel. The version of the kernel we are currently using is Mach 2.5. Some of the code was actually written by one of the presenters in the morning. And so that's great code, of course. So So we have Mach 2.5. We actually have taken a number of improvements over the years from the Mach 3.0 stack. But we didn't take the whole Mach 3.0 at this point in macOS 10 server. So one thing we are doing for macOS 10 is we are moving to Mach 3.0 because we believe that gives us the best foundations that can last at least a decade. So let me review some of the high points of Mach 3.0. First, it's a natural evolution of Mach 2.5. There's been about 10 years of evolution. Mach 3.0 is a very robust system that has been shipped in a number of products, not just Apple. Actually, Apple has shipped a Mach 3.0 as part of MK Linux. There's an interesting bridge between what we are doing and Linux here. Mach 3.0 is a preemptible kernel. So let me explain that, because you are all familiar with preemption for applications. So for an application to be preempted just means that you are blocked on some kind of kernel system call, typically, and another application comes up and is able to do some work, and therefore the scheduler that's in the kernel turns to that other application. For a kernel, it's slightly different. Preemption is associated with priorities. In Mach 3.0, you have priorities along with each process and along with each kernel request. And if the kernel is processing a request and suddenly comes along a new request at a higher priority, then this new request is going to preempt the existing request. Now, why is that important? Okay, why do you care about those details? That's very important for multimedia and real-time facilities. If you don't have that, you will have a so-so multimedia performance ultimately. So for the top-of-the-line multimedia applications, you want preemption. And that's one of the reasons we went to Mach 3.0. Another reason is the ability inherent in the kernel to do symmetric multiprocessing. Currently, we don't have any hardware that has multiple processors currently shipping, but this will enable us to do so in the future. And we're not obviously going to scale to like, at least not in the foreseeable future, to like, you know, the 256 processors and that kind of machine. But that will give us the opportunity to have some pretty good scalability for quite a wide range of server products, notably. IOKit is the device driver model that we created for macOS 10. It is object-oriented. You program IOKit in embedded C++, which is a very safe, very clean subset of C++ designed for embedded systems. It's a subset, so you don't have, you know, all the goodies that you can hang yourself with in C++. So because it is object-oriented, it's actually very easy to write drivers, and we've already seen that over the last few months, where we were developing device drivers based on IOKit. At the same time, we were developing IOKit, so it was not like necessarily stable at all times. However, we've made tremendous progress, and that's due to the object-oriented nature. When you devise a new driver, you can just subclass and redefine what you have to redefine. You inherit from a base class, and we ship with a wide variety of base classes. IOKit also very closely maps the hardware, and that's definitely makes it much easier to develop like wide class of device drivers. Mach 3.0 is also the foundation for BSD 4.4. Here, it's again an open standard, and we're leveraging years and years of expertise in the Unix community. There's lots of really great sides about Unix. Just to reassure you, Unix will not show its ugly head in macOS 10. Unix is only for the people who want to use it. System administrators, some developers would like to use that. And it's a very good basis. I mean, there's a number of tools you can have in the system thanks to Unix, but hidden. And of course, for macOS 10, just like for macOS 10 server, the entire code base for the core OS is going to be also open sourced, and that's what we call Darwin. So that was a very brief overview on Mach 3.0. Let's continue to move up the stack and to focus on the graphics layer. In macOS 10, we have display PostScript. Now, display PostScript has had some tremendous advantages for the publishing market, because fundamentally, its imaging model is PostScript. And that means that what you see on the screen And what you see on the printer is the same. Okay, there's none of this font mismatch that happened in so many other systems. So that's been a very good thing with display postscript. Another good thing, which is kind of required in a modern operating system, is to have a Windows server. So that means that the server is responsible for dispatching the events to the appropriate application, and also for doing certain window operations like moving the window and such things. On the other hand, there's certain sides of this postscript that are not so great. In particular, all the drawing is done on the server side rather than on the client side. So the client downloads some postscript to the server that then draws. And this was a total impedance mismatch with Carbon that wants to use QuickDraw as its kind of client library. And with QuickDraw, you execute the code on the client, and you want to essentially paint a few pixels that are in a buffer. You don't want to have like a server involved, okay, at some of the function calls. That would be too slow. So what we've done with Quartz is the best of both worlds. Some elements of display postscript, the postscript imaging model, the Windows server kind of decomposition, but at the same time, client-side drawing. Because we have client-side drawing, we can have multiple client libraries. QuickDraw is a very important one. OpenGL will, of course, be very important for 3D. The imaging model, as was mentioned this morning in the keynote, is PostScript. It's also Acrobat, because Acrobat and PDF are the same thing, of course, and that's also using the PostScript imaging model. So that means that you'll be able to draw using regular draw code, and you'll be able to record all the drawing code into a PDF file for free in your application without doing anything. And that's a tremendous advantage, again, for publishing. Because you have the PostScript imaging model, you will have the same characteristics of getting all the fonts always right. You've seen this morning some of the advanced imaging capabilities with the translucency. You also saw this morning some of the speed, which is really amazing because we've been pretty busy just putting this new graphics layer in place, and we have spent absolutely no time optimizing. Even copy bits is not yet optimized. And we're not yet using hardware acceleration. And we're not yet Altivec ready. Of course, we don't have an Altivec machine. But so if you sum up the performance tuning that we will do, the hardware acceleration and Altivec, performance is just going to be wonderful with Quartz. And we know that already. And last point is that this Quartz, this new graphic system, enables us to support a better blue box, but let me get into that in a second. So that was Quartz. Now let's move up the stack and talk about the free application frameworks that are supported in macOS X Server. Let's start with the blue box. I have to say that 2.5 years ago, when I first heard about the idea of the blue box, I was somewhat dubious. I was dubious that you could achieve a compatibility with what I thought was an emulator, and that you could achieve decent performance with an emulator. Well, of course, I've been proven wrong, and notably because the blue box is not an emulator. The blue box is actually just regular macOS 8. In fact, from the blue box perspective, the blue box is just a shim, and it's just using the operating system as a virtual hardware, and that's how we do the qualification. We consider that the whole OS X plus the shim is essentially a new CPU that is supported by OS 8, which is kind of a different perspective that explains why we've had like tremendous success with the blue box. Compatibility has been tremendous, and I think many of you witnessed that in the previous years when you took your application in some of the macOS compatibility labs and it just ran. Performance is great as well because, again, I mean, it's native code, right? It's not emulated. So these are fundamental, major success of the blue box. Okay, and we've been really, I mean, many of us at least, not the blue box team, but many of us have been very surprised, okay, by how well it has worked. However, the blue box, as it is present in macOS X Server, has one major drawback. You have to swap the screen to use it. So either you are in the Java world or in the yellow box world, okay, in the native environment, and then you use those apps and they mix, the Java apps mix in with the yellow box apps, or you are in the blue box world, okay, and you have to do this command return or whatever it is to swap the screen, okay? That's not a great user interface. And in fact, we considered that for a desktop machine, it was an absolute requirement to essentially drop the box, okay, and have just the ability to run classic applications, unmodified binaries, without having to swap the screen. And of course, we wanted to have the same high degree of compatibility, the same high degree of performance. And we thought that was impossible. At least that's what we thought until recently, until about a year and a half ago. And what I would like to do at this point is to invite Roger Pantos, which is one of the experts in the Blue Box team that has made it possible to drop the box.
Thank you. Hi. Thank you, Bertrand. Hi. So what I'd like to do for you today right now is I'd like to give you a peek into the next generation of the Blue Box. And so what I have running here up on machine 7, most of you who've played with previous versions of the developer release probably recognize this. It's the Workspace. It's kind of the classic yellow application in the same way that the Finder is sort of the classic blue application. And so, of course, with the addition of Carbon, let me tilt this up for the non-short people. With the addition of Carbon, you can run carbonized applications directly from the Workspace, nothing new there. So what I'm doing here is I'm launching the carbonized version of AppleWorks. And so you've all seen this before. And so we can create a word processing window and put them off to the side here. And now we're going to do something new. What we're going to do is go back to the Workspace and find our HFS Plus volume, navigate into it a little bit. And what I have here is the release version of CorelDRAW 6 application suite installed on this Mac OS X machine. And so for the first time ever, I'm going to click on Corel WordPerfect here and launch WordPerfect 3.5 in a boxless blue box, sharing the screen with Mac OS X applications. Thanks very much. As you can see, we can click back and forth, and we get all kinds of redraws. We have floating windows, palettes, all sorts of good things. We've been working on some other integration features as well. As an example, what I can do here in WordPerfect is I can type a little bit. This is from blue. And let's make that guy bold. It's important. And so, come on. So I'm going to copy that to the clipboard, and and we're going to paste it here. And so as you can see, we can copy and paste into a Carbon application. And of course, oops. And of course, it works in the other direction as well. And so this is just a small portion of the complete demo that we're going to give for you in our session on Wednesday, which is session 104. So I'd like to invite you all to come in. It's in the same room. Come to the session and see this, and we'll be showing you some really cool stuff. Thank you very much.
Thank you, Roger. So that was the classic environment for running unmodified macOS binaries. Let's continue to progress, and Java. So I don't have much to say about Java because actually what we have is just standard Java, right? So there's nothing much to add there. We get our standard Java from our partner Javasoft, of course, and it's a very easy port on macOS X, on macOS X server. because it's just a Unix box, okay, fundamentally at the lowest level. So last time we ported a drop from Javasoft, it took us about 2 weeks to get the whole VM ported. So that's really nice. I mean, it's a bug for bug compatible, as they say. Let's continue to move on and talk about Yellowbox. So actually, that's probably the last time I talk about Yellowbox, because now it's been renamed Cocca. So let me just go very quickly about Cocca, because there's a lot to say. It's easy to remember which name corresponds to what, because in Cocca, you have two O's. And the two O's are just like in object-oriented, right? Cocca is the ultimate object-oriented framework. It's like probably third generation or something like that. It's very rich. You have a full set of widgets. At the same time, it's very simple to use, because we spent a lot of time kind of iterating over those APIs and making them as simple as possible for you to use. It's very expressive. You can have some complex applications, complex in terms of functionality. However, the code is typically very compact. There's typically not that much code. In particular, that is due to some of the tools that come along with that environment, like Interface Builder. Interface Builder is a direct manipulation tool to build your UIs. And in many cases, for simple UIs, you have no code. You can specify some of the behavior directly with Interface Builder. So we intend to use Cocca for a number of key system apps, and you saw this morning a demonstration of Mailviewer. That's a Cocca app. Okay, so that was Cocca. That's all the free frameworks, application models that are supported on macOS X server, and that we will support on macOS X. Now, of course, I know that many of you are here to hear about Carbon. We are adding Carbon for macOS X. So let me just explain very quickly what Carbon is. After 15 years of evolution, we took a good look at the toolbox, and we found that there were a number of functions that we were not so proud anymore of. So we ended up dropping them. Or there were functions that didn't work on a modern operating system with modern VM and preemption and all those things. So what we did is we divided all that set of functions in two parts. The one that were not moving forward, that's 2,000, roughly a quarter, and the ones that were moving forward. And that's what we call Carbon. Now, the good news is that even though it's a quarter that we dropped, your applications typically exhibit a much higher degree of carbonization, or being carbon ready. And we have this tool called the Carbon Data to let you measure that. And I mean, numbers like in the 90s are fairly typical. So Carbon is an API. Today, we are putting out the final spec on the web. You also have a copy of the porting guide onto the developer CD. And we have an updated Carbon Data that works with that database of what's in Carbon and what's not in Carbon. So you can run the Carbon Data app and find out with the latest spec where you're at. Of course, an API is not so interesting unless you have implementation. Well, we actually have two implementations, of course. We have an implementation for macOS X where you get all the benefits of preemption and protected address space, and that is the latest OS X code base. In fact, our team produces both. It's the same team that produces the OS X version and the Sonata version. And we also have, of course, CarbonLib, which is a library that you can use on older system frameworks and also on Sonata that enables you to run your application on 8.1 and above. So you can have a single code base, okay, for your Carbon application, and you'll be able to run that on all the platforms that matter, I should say, at this point. So that was Carbon. That's the last of our 4 application models that we support in macOS X. And those models have a lot of commonality. First, they're all equal citizens. They can all use Quartz and the Core OS in the same fashion. They can all leverage the ability to have threads, for example. Not all of them, of course, will re-export that functionality through the API, but they can all use it. All of them are based on Quartz. And the Quartz is also what I should have mentioned, what enables the boxless blue box to work. We have also devised a new packaging for Cocca application and for Carbon application that is very simple. Over the years, what used to be a very simple application that had everything you needed in a single file has become like an entire tree of stuff. Okay, you have like resources, you have templates, you have just about everything, documentation, HTML, whatever. So we want to go back to something simple. We want to go back to a system where you can take your application package and drag it where you want it to reside, and that's your installation. No installer, right? So we have devised this new package that in a single package can have multiple binaries, okay, for different OSs. So you can have a binary for OS 8, a binary for OS 10, if they have to be different. They don't necessarily have to be different, but if you want to take some advantages of some of the native APIs of OS 10, you can have a different binary there. Also in the same binary, you will be able to have multiple localizations. That means that the same binary can be localized in French, in German, in Japanese, all within one package. That package can be installed on a server. That means that everyone who runs that app of the server will be able to get the version that corresponds to their system, whether they're using an OS 8 platform or an OS 10 platform, and to their language, which I think should be something that is quite useful, especially in Europe, where you have like people with different languages who cooperate. For all the application frameworks, we also have devised a new set of common services that are used in each of the stack. You've seen a demonstration with Roger of cut and paste. Okay, so the clipboard, of course, is shared, okay, between all the different systems, all the different frameworks. We also share Apple Events. Apple Events is a primary means of inter-process communication. That's how you open a document programmatically. So that's what all those environments use. This is also where the drag manager lives, okay, in this common services layer. And we've made a new framework for that layer that we call Core Foundation, with a great API that enables you to access those services and also some utilities like Unicode utilities. There's a number of facilities that are part of this Core Foundation, like collections, things like that. So I strongly recommend that you check out the sessions on Core Foundation. There's a lot of great new stuff there. So what I would like to do at this point is to introduce Christine O'Sullivan, who is Director for macOS 10 integration, and that actually means a lot of things that happen in her group. And her group is notably responsible for taking all those components and integrating them together in the CD that you will have today.
Great, thanks, Bertrand. Thank you. So Bertrand's just talked about how we're building macOS 10. And Roger has shown some incredible progress, I think, with classic applications running on 10. I think that was really cool. Actually, I just heard somebody say they've made the impossible possible. So what I'd like to show is a larger number of applications running from different application models, all running in the same environment. So why don't we get going? So let's launch AppleWorks. Seems to be very near and dear to all of us in our demos. A lot of applications that I'm going to show here that are carbonized were actually carbonized by many people on my team. I'm going to open a document that I prepared earlier. So let's go to the menu bar and select Open. And as you can see, Carbon applications utilize navigation services, which is working really well on macOS 10. So let's open the file, select the document. As you can see, it's pretty content-rich. Now that I'm here, why don't we just add that this is a carbonized AppleWorks. Change some text. Center, justify. Maybe it's a little busy, Bertrand. I don't know what you think, so I'll take an image out. Oh, that was the iMac. Actually, I love the iMac, so I'm not going to do that. So I'll just undo it. So technically, there's a lot going on here, but to the user, it just works. You are going to hear that many times this week, but that's a great validation of Carbon. So let's quit out of this application and go to the next app. This is a fun little application that an engineer on my team wrote and carbonized it over a weekend. It's got some graphics, animation. But what's really interesting about this application is that it heavily utilizes the Carbon Drag Manager. It was also written with PowerPlant using base classes. And we continue to work very closely with MetroWorks, and we're delighted that they're making a carbonized version of PowerPlant available. So I'm sure you may get a hold of that during the conference. So let's log out of this and launch a more interesting application. This is Fetch. For those of you who are not familiar with Fetch, I believe it was one of the very first file transfer applications actually written for the Mac. It may even have been one of the first graphical FTP clients available. So this is a carbonized application. Let's log in. Whoops, let's not log in. Let's put in my password and ID before I log in. And let's download some files that I have on a server that I'd like to show you. So they're in this folder. Let's select a few files and get them. This is a great demonstration again of Carbon. It's an open transport application that's running really well on top of macOS X's BSD networking foundation. So now that I have the files, I've saved them to brought them down in a predefined folder on my desktop. Let's just go drag an alias of those files on the desktop. What's particularly interesting here is, let's open Appearance Sample. This demonstrates the progress that we've used with the Carbon Appearance Manager. As you can see, the windows look really nice. The controls work really well. Pick a pop-up menu, change to a different tab. I think that looks really nice. What's even more interesting, as Bertrand talked in his speech earlier, is that this very same binary just runs on macOS 8 using Carbon lib, which is simply a shared library in your extensions folder. So never let it be said that we didn't do the same demo on macOS 8. As you can see, same code base, working great.
Switch the screen.
I'm sorry?
We're not showing the OS X screen.
Oh, can we change to the macOS 8 screen? I guess the technicians are eating their own dog food as well. So as you can see, let me quit out of that and start again. Very same code base, looks great, same binary. In fact, I'm saying the same code base. It's actually the very same binary running on macOS 8, and it just works. So just for your information, we've included this Carbon. Thank you. Just for your information, we've included this Carbon sample source code on the developer preview CD that you picked up today, so this should be really useful to you as you carbonize your applications. So let's bring up a Cocca application. This is Mail Viewer. You saw it this morning in the keynote. This is an awesome application, which is, it fits in with extensible internet mail protocols like IMAP, LDAP, POP, but it also drives the next level of innovation, bringing some very media-rich email facilities. So what does that mean? Well, as you saw, this morning, and let me just bring up another document, not alone do we have the ability to display stylized text, but also inline graphics, which is just, I think, beautiful. And as you saw also this morning, let me create a new message here and grab a PDF file that I downloaded using Fetch a few minutes ago and simply drag it and drop it into my mail. As you can see, that renders inline just beautifully.
And Christine? And again, it should be mentioned that this is Quartz in action here. And this is the unoptimized version of Quartz with no fine-tuning of the copy bits and no hardware acceleration.
Right. So let's log out of this account. And log into a different account. So let's type in a different username. macOS X has the notion of a virtual desktop, enabling multiple users use the same computer. And I hope this is obvious on the screen, but not alone can you have multiple users, but you can have multiple users with multiple localized interfaces. So as you can see here, the user interface that has been invoked is Japanese, displaying 2-byte characters. In fact, this is the second year that we are having a truly international conference. We have one once a year now. I think historically we used to have them in various countries. So I would like to extend a welcome to our overseas attendees. As you know, this is a pretty international set of presenters here, but also I practice something which I guess I should do right now, and I hope I don't offend anybody, but it's domo, konnichiwa, irashi, mashita. which if for the people that actually have helped me deliver that, I hope it was seamless and it didn't say anything other than a very warm welcome to those of you that understand Japanese. So as I conclude, let's very quickly launch another Cocca application. I don't know if you caught this earlier, but in Bertrand's speech, a lot of the system applications that we've written are also Cocca applications. This is the user preference. As you can see, very obvious that it's the user preference. I'm going for the safest bet here, which is the mouse. Or maybe it's not. And as you can see, it's fully localized. And I think the key point that we're trying to make here is that macOS X has a simplified application packaging format that both Carbon and Cocca apps can take advantage of, meaning that we can have multiple localizations in a single package. So what you've just seen today is a wider variety of applications running incredibly well, I think, on macOS X, and heavily taking advantage of system capabilities and services. So I thank you for giving me the opportunity to show all this great stuff. I think the team has worked incredibly hard, and voilà, Bertrand, c'est à toi.
Merci beaucoup, Christine. So at this point, we have covered this layer of application frameworks with the 4 application frameworks supported equally well by macOS X. Let's continue to move up the stack and to go to the primary user interface of the system, coming with the system, which in macOS X server is Workspace. One thing that we decided very early in the history of this project is to bring you a familiar desktop. And we decided to replace Workspace with a carbon finder, a carbonized finder. But then we decided that this didn't go far enough along. And so we decided to bring you the enhanced desktop, and that's a new carbon finder. So what I'd like to do at this point is to ask, Ken to come back and show us the finder and things built on top of the finder.
As you get your slides back.
That's right.
The long walk across the stage. So we saw in the keynote this morning a very important application that will play an integral role in macOS X, namely the Finder. As was mentioned, we certainly are investing heavily in various components in the system using both Cocca and the Carbon environment. And the perfect application to base on Carbon, we believe, is the Finder. Let me just set the stage a little bit on the demonstration. This is an exceptionally early look at the state of the Finder in development today. It's not on the developer preview CD that you've received. I think it takes the words pre-alpha to a new dimension. But there is enough running, and we're exercising enough of the Carbon toolbox that we think it's a great demonstration to A, show the completeness of Carbon, and B, a hint as to what the desktop user experience is going to look like for macOS X. As was mentioned in the keynote, the Finder is going to allow you to navigate through huge repositories of files in a very, very seamless fashion. In this pretty simplified demo, we have just a couple hard drives and our connection to the network. The hard drives, it used to be, as a longtime Mac user when I got my original Mac 128K, that navigating through a 400K floppy was a pretty simple task. You had maybe 90 to 100 files on the whole thing, maximum, actually probably 20 files. Today we have a Power Macintosh G3 that we can connect 100 gigabyte worth of hard drive space. People have partitions stored all over. The depth of the hierarchies is incredible. So having a browser, a view by column mode that allows us to quickly go through and navigate the contents of our hard drives is going to be an incredible, incredible time saver. We certainly support the view by icon approach. People like to store their files, their icons aligned the way they like them. The Finder is certainly going to support all of that capability. But we're really, truly going to blend what's positive of the Finder today and embracing this notion of much more advanced networking. As Phil demonstrated in the keynote, the ability to turn on a shelf. Just think of this like a favorites area. Just like you have favorites in a web browser, being able to go to a given directory. Let's say we go to our application folder. We can take that and just put it either for as a permanent basis or temporary. Then again, navigate across the network. I can go into the engineering department, and Bertrand's home directory on the network is all there. This truly represents the elimination of the chooser, and I know that Steve went to length describing how network navigation was born on the Macintosh. The task at hand with macOS X is to eliminate the notion of having to go to a fundamentally different user interface simply to find information that's located across the network. Coupling that with technologies like the keychain, working on distributed file systems, we're going to make sure that people using macOS X are the most efficient browsers of information and files in the universe. And at the same time, we're trying to represent information and its content as clearly, as seamlessly, and as efficiently as possible. So I'll go back to my hard drive. Oops. I accidentally took that off the desktop. Go into our Carbon HFS Plus volume. Go to our Documents area. We'll go to the Alaska vacation. And I'll just spend a couple minutes describing the view here in the preview. We will be able to display rich information about the selected information on your desktop in a very inline, non-modal user interface. And we're going to eliminate modal dialogues throughout the system wherever we can, especially the Finder. And what we're displaying here is a picture preview. The Finder will be using QuickTime. QuickTime understands virtually every file format from a graphical sense that we care about, from PICs and JPEGs and GIFs. We also will be using text previews, be able to take text information that's associated with files, leveraging Sherlock to provide text summaries of text documents. We understand how to render PDF. So virtually every type of file that has any kind of standard associated with it, we'll be able to preview it inline in a very, very efficient process. So the real key point of the demonstration here is that we will be pushing the edge in terms of delivering a new user experience in terms of how people can navigate large hard drives, large repositories, and the network. working across a variety of file system protocols. I certainly urge everybody to go to the various Mac OS X sessions. The file system team will talk about the extensibility of the underlying file system in the system. The other message is that this is a Carbon application. It is in our interest to make Carbon great, because one of the most important applications that we ship is Carbon-based. I think that is a very important statement. Now, so far, you've seen mostly Apple products up and running on the system. We've had Apple Works. Now we're showing the Finder in terms of a Carbon application. We have been working very closely with a number of third parties as well, and we're happy to be able to share a couple quick demonstrations with you. The first one, let me just close off this window, and we'll hide our file viewer. We have been working very closely with a couple guys at Netscape that are involved in the Mozilla project. Mozilla, another open source project that's proving that this is a great way to develop software in the late 1990s. So we decided that it would be very important to show a substantial, real, intense application. This has actually been very interesting because both are projects under development. As Mozilla's been moving forward, the Mac OS X builds have been moving forward. We have the application up and running. We're actually connected live here on the internet, and again, with very little optimization. Our focus in the last couple of weeks was to get the application up and running. So the full rendering engine, the Gecko browser engine, that's part of the Mozilla project, completely ported, up and running. Let's see how our internet connection is doing. We can take a look at the WWDC 1999 giveaways. So again, this is another open transport application that's working through the OT APIs that get shimmed on top of on top of the BSD networking stack. And again, we're seeing very, very decent performance despite the lack of optimization and no hardware acceleration, and the fact that both projects are works in progress. It's been actually a pleasure to work with the folks at Netscape, and we're working with them to ensure that we get the carbonized version of the Mozilla source base recontributed back to the public projects. Hopefully that'll happen very, very shortly. So that's exactly.
And Ken, I also want to point out some metrics about this project. I've heard the number of 40 CFM libraries that have been carbonized. Actually, many of them didn't need any work because they were just kind of non-UI kind of things. And I believe there's several thousand...
10,000 source files.
10,000 source files, which is significant. Significant effort in just a few days.
There is no excuse for any of you to not go back after this conference and start carbonizing your applications. But to further prove the point that Mac OS X is ready for you to start doing Carbon development, I'd like to invite on stage Theodore Gray, who's the co-founder and director of user interfaces at Wolfram Research, to show and talk about the carbonization of Mathematica. Okay.
Okay, so I guess basically the reason I'm here is because when people think about, big fancy applications, what would be sort of the most complicated thing you could get running on OS X, they think about Mathematica. At least some people do. So we'll admire our banner, and now we'll go down. Let me tell you a few things that make Mathematica particularly relevant in connection with OS X. Mathematica comes in two parts. There's a user interface portion called the front end, which was originally developed on Macintoshes and always has been sort of a Macintosh-like application. And then there's a computational kernel, which was originally developed on Unix machines and always has been sort of a Unix-like thing. Also, Mathematica was bundled on Next machines when they first came out, so we have a lot of experience with the sort of, yellow box Next project builder world. So when we thought about doing an OS X port, there were lots of choices. What should we start with? Should we start with our Unix sources? Of course, the front end has since long been ported to other systems like Next. Should we start with Unix sources? Should we start with Mac sources? Should we make a CFM application? Should we make a Mach application? Should we use CodeWarrior? Should we use Make and Project Builder? We've done all of those different things on different kinds of platforms. So we decided to just choose both in each case, since we had two components. So for the front end, we carbonized the ordinary off-the-shelf Mac code base. We build it using CodeWarrior. I hope I spelled that right. Just like an ordinary, Mac application. The kernel we decided to build from Unix sources using Make, our iMake files, I believe straight off of the next version, such as it is. And it was really only, because we had both those options that we were able to do in basically less than 2-person weeks overall. I wouldn't say complete, but a very close to complete port of both portions of Mathematica. And it actually works. And let's see if that's in fact true. It worked about an hour ago. So let me magnify this. Look at that. Pop-up menus in the window. Okay. 2 plus 2. And wow. Okay. So by the time you get into 10,000 factorial, that's a fairly good-sized number. The performance is good. So think about what just happened. I typed 2 plus 2. That's a CFM application using Open Transport calling to Berkeley sockets layer, which is in turn communicating to a Mach executable that actually does the calculation, running on the same machine, of course. The answer is communicated back again and displayed quite seamlessly. So in fact, this sort of encapsulates in one application some of the demos that you just saw. It's both a CFM app and a Mach app running at the same time, working sort of nicely. So of course, when Apple asked us to produce a demo, we thought, well, let's make some animations since it's Apple, So let's just show you, for no particular reason, some Mathematica-generated animations. Actually, the amusing thing about these animations, it's altogether about a gigabyte of PostScript that represents these animations, and I only had access to them in PostScript form. In order to do this demo, I had to render them down to bitmaps, and I only had a pretty short time to do that. And I thought, well, all right, I'll do that on my old 8.5 machine because how else am I going to do it? And it was kind of getting, time was getting short, and I realized, well, wait a minute, if I fixed file saving, maybe I could use the 10 version to do some of this rendering, and maybe it wouldn't run out of memory all the time and crash. And sure enough, about half of these animations were actually rendered using the 10 version, running on OS X, straight out. Not, really only had to fix a couple minor little things to make that possible. There's no particular reason I'm showing you these. I just thought they're kind of cute. Oh, that's sort of embarrassing. Okay. There's another one there. The artist, by the way, is Michael Trott. He has a book coming out. You should look at it. Yeah, so I kept running out of memory. And, I mean, that's amazing. It's about 1 million lines of code. And in less than 2 weeks, it was not just a demo, but I was actually doing work with it, getting stuff done that I need to get done. And it really, convinced me that OS X is here, it works. So just quickly, what are the advantages that we see under OS X versus regular Mac? People expect Mathematica to do a lot. They want to calculate 1 million factorial. I did that last week, 2 minutes, well, a minute and a half. It takes a lot of memory to do those sort of open-ended calculations, and you can't predict when Mathematica starts up, how much memory is it going to need. You need a real operating system to support an application like that. The fact that you have a real production, sort of a real software engineering environment, in other words, Unix, it means we can do, maybe I'm being a little hard on them, but whatever. I mean, it's great. Our production people are going to be absolutely thrilled that they will be able to integrate our production builds into the same, system that builds all the other versions. We can run our continuous, automatic testing that runs 24 hours a day on lots of different platforms except Mac. Nightly automatic builds to see if anybody's introduced a bug. All that will just work absolutely smoothly. And from the end user's point of view, one of the things that's always been possible on other platforms is to use Mathematica, the kernel in particular, as an embedded compute server within other applications, where you use our Mathlink protocol to launch a sort of faceless kernel process within some other application. You might launch many of them, and they're just kind of running there in the background, doing computations or whatever your application needs them for. That's been possible on the Mac, but not really very practical. With OS X, that should just work. Same as with any kind of Unix machine or anything else. So in conclusion, good luck, but you won't need it. This stuff really just works. In fact, we actually spent most of our time in the last week taking out stuff that we put in earlier to work around very, very early versions of Carbon and just putting it back to the way it was in the ordinary sources, and it just works. So, thank you.
Thank you, Theo. So I just learned something, 1 million lines of code in 2 weeks. Now, it's been estimated that there's somewhere between 1 billion and 2 billion lines of macOS 8 code. So this is a challenge and a quiz. You know, how long will it take to carbonize this code? And if you answer 2,000 weeks, that's a wrong answer because there's probably 1,000 of you who can start now and carbonize in 2 weeks. So that was the enhanced desktop with applications on top of that, which of course make for the entire user experience. And this is the whole stack. This is the macOS 10 stack. This is what we are building now. And just to go back to the original kind of premises, this is exactly how we're building macOS 10 by combining the strengths of OS 8 and OS 10 server for macOS 10. Now you saw this CD appear right there. And you may wonder, okay, so what's on the CD that many of you have gotten today? So if you haven't gotten the CD, you should get in your bag a coupon, and you can exchange the coupon at the Apple info desk and exchange that for the developer preview macOS 10 CD. So what's in it? So you've got most of the bases here. You've got Mach 3.0, you've got IOKit, you've got Quartz, and I'm sure that's kind of one of the key for you. You've got Carbon. You've got both Carbon for macOS 10, with which the demos were done, and Carbon Lib going back to 8.1. So what we hope with this is that you'll be able to carbonize your application, whether you choose kind of the cross approach or whether you go directly native by moving the source files and compiling natively, and that you'll be able to check that it does work on OS 10, just the way our demos have demonstrated that. Of course, you'll have Cocca. You'll also have the classic environment. This is not yet the boxless blue box. This is still the box full, okay, so swap the screen kind of blue box. And you've got a number of tools, of native tools, to help you build your Carbon or your Cocca application. There's also a companion CD from our partner MetroWorks to have Code Warrior and a set of tools that enable you to build cross, okay, on OS 8 or on the blue box, and then try your application, run it on the native side. And the spec, there's a version on the web, and there's a porting guide on the CD itself. What's coming up? Okay, so of course we are, I would say, about 80% done for Carbon. We need to be 100%. So we will be very busy, I'm sure, completing Carbon, completing all the managers that we don't have yet, and polishing, of course, the implementation. There's a lot of polish that needs to be done throughout the stack. We are very aware of that. We need to do some performance tuning, and we'll do that just like we did for macOS 10 server. We will also have the switch away from Workspace and to the Carbon Finder for the next major drop. And the next major drop is, of course, the developer preview 2. That's in late summer. That's our engineering target. I think Steve this morning said fall, and that's good. That's the marketing target. So for once, we are a little before. You will also have, in the same time frame, the DDK for IOKit that will enable device driver development. We may have a few keychains in the meantime. We haven't figured out all those details, but we may do that. And we will do another drop of Darwin, of all the open source code for the core OS around the same time frame. And we, of course, are getting ready to ship by the year end, to ship in early 2000. That's the roadmap for the product, and this is a roadmap for the sessions. I'm sure you can read that on your program. I just want to mention that there's a repeat of the Carbon sessions. There's 2 Carbon sessions, 2 Carbon overview sessions. So if you cannot make it to the first one, or like Star Wars, you really want to see it twice, that's what you should do. Thank you very much.